Hey guys, here I am from my weird little hotel in Colorado Springs, actually Woodland Park, Colorado, and I'm going to be recording the podcast for Lab 3.2. Apologize, my voice sounds a little crazy. Let's have our morning coffee. Get going. This is a pretty simple lab. Again, let me remind you that my name is Ramsey. Yay. And this is what I look like. Are these big lips right there? And my body. Yay, yay, and I keep disappearing. It's not fun. Okay, so basically, I give you all these procedures to go through. Um, but in essence, we're just looking at this one reaction. And when we see an aqueous, we can think about it as if it were liquid, okay? So initially, the temperature of this is going to be somewhere around 22 degrees Celsius. And in this reaction, it's going to go up. Let's say it goes up to 30 degrees Celsius. So when temperature goes up, we know that the sign on delta H is positive. And the answer is that the system absorbs heat from the surroundings. Now, if the system absorbs heat from the surroundings and we touch the surroundings, that means that we are going to feel. I totally screwed this one up. This should be a negative. Sorry about that. Hopefully you caught me. The system release heat to the surroundings. And if we touch the surroundings, we feel heat. So it's exothermic. Here's the reaction. Here's the surroundings. It was releasing heat. And there's our thermometer. So that's going to go up. Good job, Mr. M. All right, what equation would we use for delta H if the word bond was involved? We'd use our trusty delta H is equal to sum of the bond broken energy minus the sum of the bond formed energy. And let's go up to this reaction and remind ourselves that the reactants are broken and the products are formed. Here we go. Based on this reaction, what is the sign of delta S? Well, we're starting with liquids, and on this side we make a gas. The reaction increases in disorder, so the sign on delta S is positive. What equation would we use to calculate spontaneity? Well, we have two equations so far. We have our electrochemistry equation, and we have our thermodynamics equation. And this is the one that we are going to be using. Common sense tells us that we had a delta S here, we had a delta H up here. We're going to go for that equation. Okay, spontaneity conditions. So if delta G equals delta H minus T delta S, and this is minus, and this here is positive, we're going to look on our chart, and it's going to be spontaneous at all temperatures. Okay, next one. All right, same questions are going to be asked in this one. Why don't we notice initially then that we're starting with a solid and liquid and going to liquids. This is decreasing in disorder, so delta S is going to be negative, decreasing in order. In this reaction, we started with like 22 degrees Celsius and went down to like negative 2 degrees Celsius. Delta H is positive. System, or the reaction, absorb heat from the surroundings. Okay, so if we touch the surroundings, we are going to feel cold. So think about that drawing that I drew last time. In this case, reactions taking in heat from the surroundings, so the temperature is going to go down. Okay, again, delta H equals the sum of the broken minus the sum of the bonds formed. This is because we see the word bond. Here is broken. Here's formed. See above, we calculated that. Delta S is going to be negative or less than 0. We know that delta H is going to be T delta S. Okay, so delta G equals delta H minus T delta S, and this is positive, and delta S is negative. Okay, this is going to be non-spontaneous at all temperatures. Okay, notice this is going to be a minus and a plus. T is either going to be greater than or equal to 0, so this value is always going to be positive. Right, last reaction, let's look at it again. Solids and liquids going to liquids and liquids. In this case, entropy is increasing. Delta S is going to be positive, or you could also say delta S is going to be greater than 0. These are the broken bonds. These are the formed bonds. And this one, I believe, increased in temperature as well. 20 degrees Celsius. I think this one up to like 50 degrees Celsius. So it's going to be exothermic system releases heat to the surroundings. Remember, we touch surroundings. That is what we touched. So delta H is equal to the sum of the bonds broken minus the bonds formed. In this case, delta S equals positive. Okay, you can see above. All right, we'd use delta G equals delta H minus T delta S. A lot of repetition here. Delta G equals delta H minus T delta S. This is negative, and this is positive. Is it? Solid, liquid, liquid, liquid. Yeah, that's positive. That's negative. So this is going to be spontaneous at all temperatures. All right, let's go on to the AP problem. Answer the following. So we're not going to do this one. Hey, little guy. So we're not going to do this problem. So in this case, gas, gas, solid, liquid gets cleaner. Delta S is going to be less than 0. It gets cleaner. One way of saying that is less disordered. There's less disorder. Okay, so how is delta G affected by an increase in temperature? All right, if delta G equals delta H minus T delta S, okay, delta H is negative, minus T, in this case, delta S is also negative. All right, so it's going to be a positive. So it's spontaneous at low temps. Now, every time I say this, guys, you can look on your chart here that I gave you. I'm not just doing this out of my head. I'm thinking about that chart. Low temps. So increasing temp would decrease spontaneity.